Hello everyone, myself Jyoti Katigi, Assistant Professor ENC Department BGMIT Mudod. Okay, today we'll do the experiment number 7. Aim of the experiment is design a 4-bit R2-2R op-amp digital to analog converter using 4-bit binary input from toggle switches. Okay, this is the aim of the experiment. The circuit diagram for this R2-2R op-amp digital analog to converter is shown in figure. Okay, here we are using 4 1K resistors, those are called R, and op-amp 741. And next we will use the 2R resistors as 2K resistors. This is the 4-bit R2-2R op-amp digital to analog converter. In this we are using op-amp in a non-inverting mode, and the feedback resistor we are connecting to pin number 2 to 6, and output we are measuring across the pin number 6 using the multimeter. Okay, see here in the diagram 4 switches are used: D0, D1, D2, D3, where D3 is the MSB bit and D0 is the LSB bit. Okay, here reference voltage we are giving as 5 volts. Then plus VCC we are giving pin number 7 for op-amp as 12 volts, pin number 4 minus 12 volts. For example, in the diagram I have shown the most significant bit D3 I have connected it to the MSB bit, that is connected it to 5 volts, and D2, D1 and D0 I have connected it to ground. Okay, we are considering, for example, here D3 as 1, D2, D1, D0 as all zeros. For this digital input, you need to measure what will be the output voltage. Here I have shown the output voltage equation as V0 is equal to V reference RF by R into D3 by 2 plus D2 by 4 plus D1 by 8 plus D0 by 16. Okay, here we have taken D3 as 1 and remaining bits as zeros. RF as 1 kilo ohm, then R as 1 kilo ohm, V reference as 5 volts. After substituting all these values, we will get V0 as 2.5 volts. Okay, see here I have done the connections for this. In this what I have done, DC supply voltage I have given plus 5 volts and the minus 5 volts in the upper DC supply voltage. Okay, ground connection I have done. Then one more V reference voltage is also there. V reference voltage is 5 volts. Okay, the circuit connection is here. As shown in the diagram, the same connection you have to do in the breadboard using the resistance and the op-amp. Okay, here 741 op-amp is used, and the 1 kilo ohm resistors and 2 kilo ohm resistors are used. Next we will do the how to take the output from this. Now next I have connected here all the 4 switches. As I shown in the figure, the D3 switch is connected to 1, the remaining are zeros. You can measure it for any binary input conditions. Now for example, I have connected all these resistance values. 2K ohm resistors I have given it to 5 volts. This 5 volts I have connected it to the VC supply. Okay, if all are ones, here I have shown the tabular column how to vary. Since 4-bit R2R DAC is there, 4-bit means you will get 16 combinations from 0 to 15. Okay, now we will vary the output for, now I will keep D0 to D3 as ones, all ones. Last output we will measure now. Okay, for that what I have done here, I have connected this 2K ohm resistor 5 volts. Here I connected all resistances to 5 volts. That means how much voltage you should get? You should get 4.68, around 4.68 you have to get. Now I am getting here 4.57. Approximately you will get around 4.68. Okay, similarly you have to do you have to verify all the input connections, and you have to first only you have to calculate the theoretical values. using this formula I have shown. Okay, V naught is equal to V reference. Using this formula, for all different combinations of the input, you need to measure the output voltage. Okay, now I have shown it for one input. That is keeping all the inputs as ones. Suppose if we will keep all the inputs as zeros,